B, sir.
What is the voltage across capacitor?
B, sir.
Okay. VC is equal to 1 by C integral of I dt. Now write the loop equation here. Current is flowing from minus to plus V minus voltage across. In the direction of current, you can take plus and minus. Minus VR minus VC is equal to 0. V minus IR minus 1 by C integral of I dt is equal to 0. Write down the steps. That is the voltage across capacitance. 1 by C integral of I dt. What is the voltage across inductance? Inductance at inductance, what is the voltage? There is no inductance here. But what is the voltage across inductance? VL is equal to L into di by dt. In the RL transient derivation, we have derived. You have to practice the derivations. If you are not practicing the problems and derivations, you can't remember these things. Now see here. Now I am bringing V to the right hand side. Okay. Now we have to get the first order differential equation. We have to get the first order differential equation. If you want to get the first order differential equation, that integral should not be there. What do you have to do? If you want to remove the integral, what you will do? Apply derivative on both sides. Apply derivative on both sides. If you apply the derivative for this, derivative and integral will be removed. What is the derivative of constant? What is the derivative of V? V is constant. V is supply voltage. What is the derivative of the constant?
0, sir.
Derivative of constant is 0.
0.
Okay. Now we have to make the di by dt coefficient 1. Divide on both sides with R. Divide the entire equation with R. Make the coefficient of di by dt 1. Make the coefficient of di by dt 1 for applying the first order differential equation. Okay. Make the coefficient of di by dt 1. Now listen here. Now what is the integrating factor? What is the integrating factor? R and C are constants. Integral of dt is t. Integral of dt is t. That is the integrating factor. R and C are constants. Now I have to determine the solution for the current I into integrating factor. That is equal to integral of integrating factor. What is K here? Your K is 0. So here K value is 0. Your K value is 0. Your K value is 0 there. Up to here, any doubts? Now we have to determine the constancy. For determining constancy, what you will do? For determining constancy, what you will do? Anyone?
We have to consider initial conditions.
What is
T is
consider
equal to
initial
0.
condition?
T is equal to 0.
Okay. At T is equal to 0, capacitor will act as
Short circuit.
short circuit. If capacitor is short circuited, what is the current?
V by R.
V by R. Because it is short circuited, I is equal to V by R. That is the initial condition. Now see here. At T is equal to 0, your capacitor is short circuited. Therefore, I is equal to V by R. Now substitute this initial condition there. I is equal in equation 2. Substitute T is equal to 0 and substitute I is equal to V by R. Now C is equal to V by R. Your constant C is V by R. Now we have determined the constant C by using the initial condition. Now substitute 3 in 2. We will get current equation. Substitute 3 in 2. Now substitute 3 in 2. We'll get this is your current transient equation. This is your current transient equation. We have derived the current equation. So in exam up to here we have to derive current equation for series RC transient circuit. For series RC transient circuit we have to derive up to here. But we will determine the voltage across resistance now. See here. Otherwise we'll draw the current. First we'll draw the current. At T is equal to 0, I is Madam, time constant of RC circuit. Madam, time constant of RC circuit. Time constant of RC circuit is time constant of RC circuit is RC. Madam, time constant of RC circuit is RC. tau is equal to RC. Time constant of RC circuit is tau is equal to RC. What is the time constant of RL circuit? Anyone?
R by L.
Time constant of what is that?
R by L.
See properly your notes.
L by R, sir.
It is L by R. For RL circuit, it is
L by
L
R.
by R. For RC circuit, it is RC. Why I am taking RC here? If we substitute T is equal to RC, RC is going to be cancelled. See here, if we substitute T is equal to RC, this RC and RC is going to be cancelled. Now see, for one time constant, substitute, that is RC. I is equal to V by R into e power minus 1 by RC. In place of T, I am substituting RC. That is equal to V by R into e power minus 1. What is the value of e power minus 1? What is the value of e power minus 1? Zero 0.3. Are you getting that? Take your calculator. Are you getting 0.6362?
Yes, sir.
Okay. Take time constant. T is equal to 2 time constants. What is e power minus 2?
0.135.
0.135. E power minus 3.
0.049.
0.049. Now take T is equal to infinity. E power minus infinity is 0. So this is the time constant for RC. Now see the circuit. Have you written?
Yes, sir.
Okay. Now see, at T is equal to 0, I is equal to V by R because this is short circuited. At T is equal to infinity, your C is open. In open circuit, what is the current? At T is equal to infinity, capacitor acts as open circuit. Once it is open circuit means what is the current?
0.
0. See, the same thing you have got here. At T is equal to infinity, your current is 0. And in initial condition is at T is equal to 0, I is equal to V by R. I is equal to V by R. At T is equal to 0, I is equal to V by R. At T is equal to infinity, your current is 0. This initial condition is very important. At t is equal to 0, I is equal to V by R. Now we'll draw the curve for this. Let us take 0.1 V by R, 0.5 V by R, 1 into V by R. At t is equal to 0, what is the value? Current
V by R.
V by R. 1 into V by R. This point. At t is equal to 0, your current is 1 into V by R. At t is equal to 1 time constant, it is 0.362. 1 time constant, it is 0.362. Here it is. Okay. 2 time constant, it is 0.135. 0.1. It is almost 0 at 3 time constant. T is equal to infinity, it is 0. Now join all these points. It is 0. It is almost 0. Okay, at infinity also it is 0. This is the current curve. This is the current transient curve. Current transient curve. It is exponentially decaying or rising.
Decaying, sir.
It is decaying. See here, if you are having only e power minus, it will be exponentially decaying. If you are having 1 minus e power minus, it will be exponentially rising. Yesterday I had told one note point. If it is only e power minus, it will be exponentially decaying. If you are having 1 minus e power minus, it will be exponentially rising. Okay. Now we will go for the, now we have derived the current equation. In exam, we have to draw up to this curve. Up to this curve we have to write. Okay. Now we will derive the voltage across resistance. Now see here, what is the voltage across resistance? VR is equal to, what is the voltage here?
IR.
IR. We know current equation. Same curve will get. Because we are having e power minus. It is also e power minus, exponentially decaying. It is exponentially decaying. same curve will take. This is the voltage across the resistance. Next we will go for the voltage across capacitance, which is very important. Madam, why I am taking the limits 0 to t? Why I am taking the limits 0 to t? Why not 0 to infinity? Why I am taking limits 0 to t? Why not 0 to infinity? See here. Suppose if you take V is equal to 10 volts, V is equal to 10 volts. Let us see, capacitor will take example I am taking. Capacitor will take some 15 seconds to charge to 10 volts. It won't wait up to infinity. It won't wait up to t is equal to infinity. Within 15 minutes, it is charging to 10 volts. Why I will take the limit 0 to infinity? I will take t is equal to 15 there. The limit I will take t is equal to 15. 0 to 15. Integral of 0 to 15. I won't take infinity because capacitor is charging to the voltage of 10 volts. Capacitor will be the voltage across capacitor. It is taking only 15 seconds. I won't take infinity there. That's why I will take the limit 0 to t. It is not 0 to infinity. Within specified time, capacitor is charging to particular voltage. Within particular time, capacitor is charging to the voltage of 10 volts. It won't wait up to infinity to charge the capacitor. It won't wait to infinity. It will take some less time only. Within a specified time, it will charge the capacitor to the voltage of 10 volts. After that, there is no more to charge. I will tell an example. See here. Don't write this. I am telling one example. Let us take 20 volts. Now, capacitor is charging. At t is equal to 0, capacitor will act as short circuit. Now, capacitor is charging with the polarity. Once it is short circuited, current is flowing in this loop with the polarity plus and minus. Now, after 20 seconds, your capacitor is charged to 20 volts. Voltage across the capacitor is 20 volts. Now, VC is 20 volts. After 20 seconds. Now, apply KVL here. From minus to plus, it is plus 20. Plus to minus, minus 20. What is the voltage? 0. Once it is completely charged, voltage is 0 in this. Now, there is no more to charge the capacitor. Now, capacitor will act as open circuit. So, t is equal to 20 seconds here. After 20 seconds, your capacitor will act as open circuit. Now, your current is 0. Okay, now your current is 0 because it's more to charge the capacitor. That's why I'm taking the limits from 0 to 20 here now. 0 to 20. Because after 20 seconds, what is the voltage here? Plus 20 minus 20. Plus 20 minus 20 is 0. If voltage is 0, your current is also 0. That's why I'm taking the limits 0 to t. I'm taking the limits 0 to t. Now see here. That is 1 by c. Integral of 0 to t. What is the current? V by r into e power minus 1 by rc into t. dt. dt is there. 1 by v by rc. V and r are constants, take outside. What is the integral of e power minus 1 by rc? That is the voltage transient voltage across the capacitor. This is the transient voltage across the capacitor. Vc is the transient voltage across capacitor. You have to remember this formula. Vc is equal to V into 1 minus e power minus 1 by Rc into T. I think you have understood why I have taken the limits 0 to T. If you are having doubt, we can ask. Any doubt until now? But in exam, you have to derive up to equation 4 only, current equation. There is no need to derive VR and VC. In exam, only up to current equation you have to derive. And the curve of the current. We have drawn the curve for current up to that. Now, I will determine the energy in the inductor. I will determine the energy in the inductor. Before energy in the capacitor, energy in the capacitor is equal to power in the capacitor into time. Power in the capacitor into time. Okay, that is power in the capacitor integral of dt. Now I can take this as integral of 0 to infinity power in the capacitor into dt. This is the formula for energy. This is the formula for energy. Now if you want the energy, I want PC, power in the capacitor. If you want the energy, I want the power. Will determine power in the capacitor. Current multiplied by voltage is nothing but power. Power is nothing but, in series current will be same. Whatever the current flowing in resistor, the same current will flow in capacitor also. Therefore, power in the capacitor is voltage across the capacitor multiplied by current. That is the power. Already I have calculated the voltage across capacitor. What is the voltage across capacitor? We have derived the formula equation 6. And current is, what is the current? This is V by R. Current you know. This is voltage, this is current. This is the power in the capacitor. This is the power in the capacitor. Now determine the energy. Now determine the energy. Substitute infinity and zero limit. Okay, this is the formula for energy in the capacitor. Half CV square. Okay, this is the derivation for RC transition circuit. But in exam, there is no need to derive this energy also. Only up to equation 4, up to current equation and the curve of the current equation. If you draw the current transition curve, that is sufficient in exam. There is no need to derive VR, VC, and PR, energy, all these things. This is the energy stored in the capacitor. What is the energy stored in the inductor? What is the energy stored in the inductor?
Half CV square.
Last class we had derived half
Li square.
Li square. This is the energy stored in the capacitor. Capacitor means you will get C here. Inductor means you will get half Li square. Because current flows in the inductor, we are applying the voltage across the capacitor. Please remember, when current flows in the inductor, energy is stored, magnetic energy is stored in the inductor. That is half Li square. But across the capacitor, what we are applying? We are applying the voltage across the capacitor, and the energy stored in the capacitor is half CV square. In capacitor, electrical energy is stored. This is the electrical energy in capacitor. But in inductor, it is magnetic energy. That is the half Li square. Magnetic energy is stored in the inductor, and electrical energy is stored in the capacitor. This difference you remember. So we have completed the derivation. Problems you will see in the next class. Go through the derivation. I will take the attendance.